Problem number 1. Write a proportion and solve the proportion. Show your work to earn full credit. Number 1. A scale drawing of a rectangular pool is 12 inches by 24 inches. The scale of the drawing is 3 inches equals 4.5 feet. What is the area of the actual pool? Alright, so let's look at that first sentence. In the first sentence, they're talking about a drawing of the pool. So they're talking about plans. And on these plans, we have the width listed as 12 inches. And it says that the length of the pool is 24 inches. And I named this the width and I named this the length because usually we call the length the longer value or the longer distance, and the width is usually the smaller distance. Alright, so I drew this first part, the first sentence, about the scale drawing. So here's our scale drawing. And then it says the scale on this drawing is 3 inches equals 4.5 feet. So that's important to know. And then the question says, what is the area of the actual pool? So take a look at this pool. We have this rectangular pool. We have to find the area of the pool. Well, how do you find the area of a rectangle? Think about it. I hope that you said that to find the area of a pool, you take the length of the pool and multiply it by the width of the pool. So that tells me if I need to find the area of the actual pool, that means that I need to find the length of the actual pool, and I also need to find the width of the actual pool. I do not know the length or the width of the actual pool. I only know the length and the width in the drawing. So what we're going to do is we're going to have to actually set up 2 separate proportions so that we can find the length and the width so that we can find the area. This is a very typical EOG type problem where there are multiple steps. So they're really testing your knowledge. Do you have a good grasp of how to write a proportion and solve it? So much so that you could do it twice in one problem. So let's go ahead and begin writing our first proportion. We're going to use the scale. 3 inches is equal to 4.5 feet. So 3 inches is equal to 4.5 feet. And then I write an equal sign. Remember, a proportion is when you have 2 equal fractions. Then I need to choose what I'm going to work with first. So I decided that I'm going to figure out the width of the actual pool first. So I only need this 12 inches. I'm not worried about the length right now. Right now I'm solving for the width of the actual pool. So I take this width and I put the 12 inches across from the 3 inches. So the inches are both in the numerator, the feet are both in the denominator. The variable I'm going to use is W because I'm trying to figure out the width of the actual pool. And then I also wanted to label here, let me grab a new color, that this, well, I guess I need the typing tool. The 12 inches represents the width in the drawing. Oh, whoops. And then the 4.5 feet is what the 3 inches would represent on the actual pool. So in real life, actually, what you see. And then this will be the actual width of the pool. All right, I've completed the labeling. We have our proportion. Now let's solve it. When solving a proportion, I'm going to start by drawing my parentheses. So we have parentheses multiplied by parentheses equal to parentheses multiplied by parentheses. And then I multiply diagonally. 3 times W gives me 3W. I bring down the equal sign, and then I'm going to multiply the 4.5 by the 12 inches. And you're allowed to use the Desmos calculator on this example, so I'm going to use the Desmos calculator in this video. All right, 4.5 times 12, 4.5 multiplied by 12, we get 54. 54. And now I've completed the step where we get our cross products. 54 is a cross product and 3W is a product. And then the final step is to identify the coefficient. And the coefficient of W is 3. So the final step is to divide both sides by the coefficient. 3 divided by 3 is equal to 1. So we have 1W is equal to, and then we can use our calculator. To pull the 54, that answer down here, just press the ANS button, and then we're dividing that by 3, and we get 18. And remember, the actual units are feet, so feet is going to be across from feet, so the width is in feet. So the width of the pool is 18 feet. And I'm going to go ahead and label that on the pool. So this width of the pool is 18 feet. Great. So now we're going to set up another proportion and solve to figure out the length of the actual pool. So once again, I go back to the scale. I start by using this ratio. So 3 inches is equal to 4.5 feet. And now this time, I'm figuring out the actual length of the pool, so I need the length of the pool in the drawing. In the drawing, the length is 24 inches, and we're solving for the actual length of the pool. So let me label this. All right, so the top portion represents the drawing. (24 inches) is the length of the pool in the drawing. And then the 4.5 is the actual. And then this length over here is going to be the actual length of the pool. All right, now I need to move this so that I can see that numerator number. And then let's multiply across, and we need our parentheses. So parentheses, oh, that didn't work. Let me try that again. Why is it not writing? Oh, I'm not on the scribble tool. Sorry about that, guys. All right, parentheses multiplied by the parentheses, and then I can start filling those in. So 3 multiplied by L, so I multiply diagonally, and then I multiply the 24 by the 4.5, and I'll use my calculator. 24 times 4.5 gives me 108. So the product is 108. Remember, the result of a multiplication problem is called a product. I bring down the 3L. And then the final step is to divide by the coefficient. The coefficient in this example is 3, so we divide both sides by 3 to isolate the variable L. 3 divided by 3 is equal to 1, so we're left with 1L is equal to, and then we take 108, so I pull down that answer, and then divide by 3, and we get 36. And this would be 36 feet. So the length of the pool is 36 feet. 36 feet. And then we need to go back to the question, what is the area of the actual pool? So the formula is area equals length multiplied by width, and then we're going to use substitution. Substitution is when you replace the variable with the number. The variable L represents the length, and the length of the actual pool is 36 feet. And the width of the actual pool is 18 feet. And I go back to the Desmos calculator and I multiply 36, so I pull down that answer, times the 18 feet, and we get 648. So 648. So since we multiply 36 feet by 18 feet, we get feet squared, or you could say square feet. So the area of this pool is 648 square feet.